Right, Chapter 1, Section 2, Imperial Measurement, Master Level. Before we actually get into problem solving, I have some proportions here that we're going to work through, just as a bit of a warm-up. So remember, what is a proportion? It's when you have a fraction equal to another fraction. Okay? Some are rather easy to solve, and well, some are not so easy. This one's quite simple. We could actually solve this just by staring at it. 1/2 is equal to x over 20. Well, common sense should tell you that x is 10. Okay? But if you want to solve this algebraically, particularly if the numbers were more difficult, we're allowed to use a handy shortcut called cross multiplication. Again, only use cross multiplication when you have a proportion. So if you have stuff over here, numbers or whatever, do not use cross multiplication. Please don't. So we work this out. 1 times 20, of course, is 20 equals. And then on the bottom we have 2 times x, which is just 2x. Okay? So what we have is an equivalent equation, but now there are no fractions anymore. So I'm just going to solve for x by dividing both sides by 2, and I get, lo and behold, 10 is equal to x, which is exactly what it should be. Let's try another one. All right. This next one is not so easy to see just by staring at it. This one you probably want to use cross multiplication, and we are allowed to do that. Okay. So 3 times 11, of course, is 33, equals x times 13. That is 13x. Please do not write x13. By convention, the number always goes first. And we want to solve for x, so that requires that I divide both sides by 13. So those cancel. And I end up with x. And 33 divided by 13, you can leave that as a fraction. But, I got a calculator. Let's see what it is as a decimal. It's approximately 2.54. There we go. Let's try another one. 7 over 6 is equal to x squared over 4. Again, we want to solve for x, so we can use cross multiplication. Okay. So let's work this out. 7 times 4, that's 28, equals 6 times x squared. Well, that's just 6x squared. Now we want to solve for x, so we can get rid of the 6 by dividing both sides. Now normally here, if this was just an x and not an x squared, we would just leave it in fraction form and reduce. But I can tell that because this is an x squared, when we're done with it, we're going to get a nasty answer. So this is just x squared. And you get 4.6 repeating. We're not done though. We want x, not x squared. So what this means is, what number such that when I square it, I get 4.6 repeating? Well, all we have to do is take the square root. So this is x. So if you have a scientific calculator, just with this number in your display, take the square root. And that gives you approximately 2.16. Okay. Last one. All right, solve for x. X over 4 is equal to 34 over x. All right. Well, we can solve for x. Let's get rid of these fractions. So let's do some cross multiplication. So what is x times x? Okay, well, x times x is not 2x. That is x plus x. X times x is x to the power of 2. Or x squared, just like what we had over here, equals 4 times 34, which is 136. Okay. But I want to know what x is, not x squared. So what number such that when I square it, I get 136? Well, I can get x simply by taking the square root of this. In fact, I'll even write that this time. I didn't last time, but oh well. Okay, so x must be the square root of 136, which is not a particularly nice number. So I'm going to put a dot here. And with my calculator, I'm going to estimate that. And that's about 11.66. Okay. So if x is about 11.66, this proportion holds. All right, now we're going to have another look at scale factors. Remember, we talked about scale factors earlier when we were dealing with the metric system. We're just going to deal with the imperial system. Well, this hasn't changed. Remember, the scale factor, if you're talking about size, it's the apparent size. Let's say how big something is in a photograph or a poster. And you divide it by how big it really is. So this is a ratio. Right? So that gives you the scale factor. Question 1. A 5-foot 10-inch person appears in a photo as being 2 inches tall. What is the scale factor? So remember, the scale factor is the object's apparent size, which is 2 inches, and we divide that by the actual size, which is given. Okay, so we have all the information we need. The only problem is, typically when we give the height of a person, we express it in feet plus however many inches there are left over. But we can't put this directly into our scale factor. We have to express it as, well, one unit of measurement. And it makes sense to work with inches, since this is inches already. So I'll write that here. This is scale factor. Okay, so that's the apparent size, which is 2 inches. So I'll go back to IN for inches, why not? Okay, so how many inches is 5'10"? Well, this is 10 inches, that's obvious. So how many inches is this? Okay, 5 feet. Well, if you think about it, for every foot, that's 12 inches. So 5 of them will be 5 times that. That is 60. So if you add the 10 inches, this gives me 70 inches. And of course, now that they're the same unit, they cancel. So our scale factor is 2 over 70, which reduces quite nicely to 1 over 35. Okay. There are different ways of expressing this. Okay, if you were to write it as a ratio, it'd be 1 to 35, same thing. Or you could actually do the division, okay, and you would get, let's see, I'll write it over here, 0.0286. This is approximately. Okay. Given a choice, I would say one of these two numbers is better, but either is fine if it doesn't say. So that's the scale factor, and obviously this is a reduction because the person in the photo, or the size within the photo, is much smaller than real life. If the scale factor of a poster is 30 to 1, and a bug's apparent size is 2 feet 4 inches, what is the actual size of the bug? All right, well, I sure hope this is an enlargement because a bug that's over 2 feet long, no thanks. All right, so the scale factor is 30 over 1. So that's the ratio of the apparent size versus the actual size. And that is equal to, and what is it we want? We want the actual size. Well, the actual size goes on the bottom. So that is x. Now what's the apparent size? Now I can't just put 2 feet 4 inches. Okay, I need to express this as one measurement using one unit. Well, I'm going to work with inches. So this is 4 inches. 2 feet, that is 24 inches. So adding the 4 gives you 28 inches. Okay. So now we can solve for x. Remember, this is a proportion, so it's a fraction equal to a fraction. So we are allowed to use cross multiplication to help speed things up. So we begin 30 times x. Okay, that's just 30x equals, and 1 times 28. Well, it's just still 28 inches. Right? So we'll solve for x. We'll divide both sides by 30. Okay. And I'm running out of space, so I'm just going to put it over here. And I think, let's see here, this is approximately 0.93, and this, of course, is in inches. So that's the actual size of the bug. Okay, so because the actual size is quite a bit smaller than the apparent size, we would call this an enlargement as opposed to a reduction. Question 3, from question 2, express the apparent size and actual size of the bug in centimeters. Okay, so we're going to have to do a unit conversion here for this. All right, so if we do the apparent size first, remember it appeared to be 28 inches, and we want to convert that to centimeters. Well, what's the relationship between centimeters and inches? Well, I guess I better give that to you. Well, it happens to be that 1 inch, it's actually exact. This is not a decimal approximation. This is bang on. 1 inch is equal to 2.54 centimeters. Okay, and that is a conversion that you're going to use quite often. Okay, so that's what we're going to apply to the apparent size. So we had 28 inches, okay, and we want to go to centimeters. So the inches have to cancel. That means 1 inch goes here, and 2.54 centimeters goes there. Those cancel. So I just multiply 28 times 2.54, and that gives me 71.12 centimeters. Okay, so that is the apparent size of the bug in centimeters. That's a pretty big bug. Okay, but we want the actual size in centimeters, and we worked that out as about 0.93. So this would be 0.93 inches. That's the same thing, times 2.54 centimeters per inch. Okay, and we work this out. Remember, this was actually approximate from before. So this is about I'll go to the nearest tenth, 2.4, and this is, of course, centimeters. So there we go. So that is the actual size of the bug in centimeters.